Hello, everyone. We are the Samsung Group, and this is our productivity improvement study.
The residential high-rise for student living is being developed and built by the Opus Group in collaboration with the Carlyle Group. It is located on the northwest intersection of John and 4th Street in Champaign, Illinois. The exact lot is subdivided and will be shared with a fraternity house on campus. The observation took place on April 12th. On this date, that the weather conditions were The weather conditions included a temperature average of 67 degrees Fahrenheit, no precipitation, high visibility, 20-mile-per-hour winds, and 50% humidity. Most of these favor conditions for construction as high visibility and no precipitations allow for no delays and no obstructed views so workers can work safely. The winds do allow for debris to be lifted up and call for goggles to be worn very strictly to protect workers. Additionally, the humidity can deform materials.
A crew balance chart visually represents the sequence of each activity in a typical cycle of a construction operation. It outlines the tasks assigned to each crew or equipment involved in the construction activity. A crew balance chart can be modified to optimize the use of resources. Flow diagrams are a graphical aid for work improvement studies that demonstrate the movement of people and/or things. In the concrete placement operation, the workers do not change their location, however, the movements of the concrete slab are demonstrated. A process chart is a chronological list of all the activities that occur within the analyzed construction operation that typically accompanies a flow diagram. The activities are classified through chart symbols adapted by the American Society of Mechanical Engineers. The following is a legend summarizing their meaning and results. As you can see, the circle represents operation, the arrow transportation, the square inspection, semicircle delay, and triangle storage. The analysis of the installation of concrete slabs performed by the Opus Design Build construction crew omits offsite storage and the transportation of the precast concrete slabs and includes 9 operations, 2 transportations, 1 inspection, and 1 delay, as you can see from the process chart to your right.
For the area of study, the project focuses on the placement and installation of precast concrete slabs on the first of 3 parking garage levels pertaining to the high-rise housing tower. This is done with a total of 9 workers. This includes 4 installation laborers, 2 crane operators, 1 helper, a construction manager, and a site engineer. The equipment used for this operation includes safety belts, 4 specialized screwdrivers, 2 boom cranes with harnesses, and 2 trucks. The process of this is that there are crews on site operating 2 cranes simultaneously to unload the precast slabs from the back of loading trucks through securement of a rope harness. The slabs are supported in 2 locations when hoisted. The precast concrete slabs are then guided slowly by at least 2 laborers to a designated location on the girders. As the laborers lower the slab, they conduct visual inspection to check for any defects.
When analyzing the existing operation through crew balances, flow diagrams, and process charts, it appears to be an adequately efficient system with a consistent cycle time. The process of lifting, installing, placing, and securing a precast concrete slab averaged a cycle time of 5 minutes 20 seconds. However, based on the original crew balance, it is apparent that many workers were frequently idle. Additionally, in regards to the process chart, many of the listed tasks require only 2 workers. This leaves an average of 2 to 3 workers idle at any given time. Instead, it would be more productive if the idle workers were to begin on another necessary task, such as preparing for the next cycle or acting as additional hands on deck. Therefore, reducing the idle time for each worker by implementing a variety of changes can increase on-site productivity. Similarly, the current equipment, while providing an efficient cycle time, is providing minimum work. The crane used meets the requirement of lifting and transporting the concrete slabs and provides a steady cycle time. However, to increase productivity and reduce the amount of cycles, equipment substitutions can be implemented. Additionally, when reviewing the construction site footage, minor problems such as material organization and vehicle placement add unnecessary costs and time to each cycle. The scattered materials and randomly placed vehicles result in obstructed walkways, which can decrease productivity as well as increase waste and safety hazards. Low productivity, high waste, and safety concerns are all potential variables for profit loss and should be addressed. The lean construction principle is a basis for productivity and cost management. It should be implemented to adjust the project waste and overall productivity. While this trend is already executed through the prefabrication of the concrete slabs, it can be used on-site by organizational means. This will allow the crew to minimize time, effort, and waste of materials while maximizing safety and overall value. Addressing the many issues of the existing operation can help to reduce cycle time and cost while increasing productivity.
A sitting crew balance is shown below, with the interval of 5 seconds, total 64 intervals, with a total time 320 seconds. So with this existing crew balance, we find there is many issues such as large idling time and unbalanced labor production, unnecessary tasks, and long crane operation time, and a long gap in between the two crew sets. And we will using following strategies to target these issues.
The cost for each crew member is summarized in the table. Here our crew consists of a crane operator, an outside foreman, and 5 building laborers. And since there are 2 cranes, we have 2 crane operators. These are their hourly compensations. So altogether, the hourly rate of the crew is $365.80, and the hourly rate of the crane rental is $395.76. So the total hourly cost is $761.56.
Proposal 1 is to propose an authoritative foreman to enforce crew balance. As of right now, the foreman on site is lenient and laid back, which calls for a lot of communication between installers during cycles. While communication among workers is acceptable and encouraged, the crane is the limiting resource on this project and is therefore the key determinant in the cycle time. If we were to enforce a stricter management and reduce the communication during cycle times, the average cycle time would be reduced by 100 seconds. This estimates $21.15 save per cycle. Therefore, more cycles will be completed in a workday, and this will shorten the project duration and reduce indirect costs overall.
New crew balance is chosen for the proposal 1, and we've been saved 70 seconds from the baseline. We targeting solved idling time and productivities.
So as we mentioned before, the total time saved is 100 seconds, and the cost of this labor time is $21.15 per cycle. And although this may seem insignificant, repetitive tasks such as this one make savings like this significant. As the project progresses, this $21 will accumulate rather quickly. Also, as mentioned before, since the reduction in the cycle time will result in a shorter project and decrease all the direct costs, any additional costs that might come with this is additional training for the foreman if necessary to help them with their leadership.
Our second proposal is to implement a new crane to support a heavier load. This will ultimately change the amount of cycles and reduce the time cycles itself. The old crane was a HTT 8675 Series 2 with a capacity of 75 US metric tons, and it is a boom 4-section length of 41 to 127 feet. The maximum tipping height is 230 feet. The new crane that we will implement will be an HTT 866 110, which has a capacity of 110 US metric tons and a boom 6-section length of 38.3 to 164.1 feet. With this, the maximum tipping height will increase to 262 feet. This will ultimately allow later in the project to have a greater area for the concrete slabs. We can increase the width, which will ultimately decrease the activity and the project duration for this project.
A new crew balance is due after we get the proposal 2. There is 45 seconds being saved from the baseline, and we're targeting from the operation time of the crane.
The cost associated with Proposal 2 would be to change the 2 lattice boom cranes from a 75-ton capacity to 110. The cost of the 75-ton is shown, and the new crane cost is shown below. So the upgrade cost would only be $54.46 per hour. And although this would be an upgrade cost, our cycle time has been reduced by 1/7. Therefore, our labor cost would also be reduced to 1/7, and this would result in $82.26 saved hourly, which yields a net income of $54.46 hourly.
Proposal 3 focuses on site mobility and safety. The way we do this is introducing a new site layout, which minimizes as you can see in the current project site layout, we have scattered trailers, trucks, and dump sites all throughout the site, with providing little to no access for certain trucks to get out to either enter or exit the construction site. The new construction site, as you can see in the proposed layout, has the trailer trucks organized to the rear where they will not be moved for the entire project. Trucks uniformly organized near the exit with easy access in and out. The cranes are located out of everything's way to allow access for work.
There are very few costs associated with Proposal 3, as this does not change the crew and does not change the crew balance. However, this decreases indirect costs. This decreases accidents, so there will be no delays or decrease in productivity or no chance of it happening. Additionally, decreasing accidents lowers the EMR rate of a contractor and therefore lowers workers' compensation rate. If all 3 proposals are implemented, this would be the most optimized crew balance. The total time would be 5 seconds and 44 intervals. This reduces idle time, improves labor productivity, reduces unnecessary tasks, improves crane operation, and makes the job site a more organized and safe place to work, which are all part of lean construction principles, which we have used to come up with our proposals in order to increase productivity on site. Thank you, and we are the Samsung Group.